So, a bandsaw is one of those tools that I've always wanted but never had a huge use for because it's kind of like a lathe or a milling machine. It seems like the sort of thing that when you have it, it unlocks a whole bunch of really cool uses and just new avenues to performing, cutting tasks that you can't do with really any other tool. Yeah, a bandsaw is a very specific tool. Um, and that unlocks some really cool uses for it. And getting into metal casting, one of the big pain in the asses is cutting off, cutting up scrap metal and also cutting off, like sprue and cutting up old castings. It's really laborious with a hacksaw. It can just be super tiring depending on how thick the metal is, really time consuming, and it just sucks. So having a faster way to do that is really desirable. It's one of those things I've looked every now and then on local classifieds, even before this, and you always see big, larger two-wheel bandsaws for hundreds and hundreds of dollars, way out of my budget. But I found this Craftsman Sears 3-wheel 10-inch bandsaw, and I think 10 inches is this distance here, for $100 on local classifieds. And it actually came on this pre-made metal stand, and with a little light added up onto the top of it. So I know you can get these a lot cheaper normally, but they don't come with a stand. It does make it a little more bulky, but I have a lot of cleaning and organizing I need to do in here anyways. So having it on its own stand would probably be useful. So I'm going to be converting this into a metal cutting bandsaw, at least as best as I can. So normally these just cut wood, and they run about 2,000 linear feet per minute, and I'm going to try and slow it down to about 500 feet per minute. So I have done some tests on this, and I've already done a bit of work on this. I'm filming this a little out of order, just because it makes more sense that way. We have three about 5.8 inch wheels on here. I think it was 5.8? Something like that. Anyhow, it's a 1750 RPM motor that has a 120 XL or 12-inch loop belt on it. Oops. If I can get that to focus. And that spins this wheel at about 1100 RPM. And so according to a calculator, that's a little under 2,000 linear feet per minute on the blade. For cutting steel, you want 100 to 250, I believe. And aluminum, you can go a bit higher up. So I actually have another one printing. But I designed a wheel that's going to end up taking a 170 XL or 17-inch loop belt. And it's this, but in carbon fiber PETG. Not printed horribly. And also with a backing ring to prevent the belt from sliding off. So that right there, along with the larger belt, is going to drastically reduce the speed to about 500 linear feet per minute. I think a little under 400 RPM on the wheels. So that should be a lot safer for cutting aluminum, brass, maybe a little bit of small steel. I can't imagine I'm going to do much, though. That might be for, like, destroying hard drives. I'm also going to be taking off this stupid light thing here, probably putting an LED strip that comes here and maybe extends a little bit out on this side, just to have a nice sort of more modern light to it, and get this big thing out of the way. I'm potentially going to cast this gear in aluminum if I can, although I think the plastic is actually going to perform quite nicely. And then for blades, I had a local company make up some new custom ones. So these are 56 and 7/8 inches long, half-inch width, 0.25 gauge, and 24 teeth per inch. These are a really nice, hardened metal cutting blade that works really, really well and does happen to fit the bandsaw. So this normally takes, I think, either 1/4 inch, or this looks like it might be like 1/8 inch diameter blades. It came with this really crappy wood one that barely works. So you can see here, there's a significant width difference that may cause some issues, but in my quick tests, the larger blade does run quite well. However, I'm not able to properly tension it, so it does rub a little bit down here. That's because I can't get it tensioned properly. I think part of that issue is that all of these are sintered, or maybe just regular brass bushings, and they do heat up a little bit during use. So I took some measurements. It's 10mm ID, 26mm OD. I ordered some shielded bearings. Those should be here this week. And I'm going to replace all these with proper bearings instead of bushings. And that should hopefully, well, first of all, reduce friction, make it run a bit smoother, and also let me tension it better. One of the things about metal bandsaws is that they don't have rubber tires. That's just because I guess the metal chips can embed in them, and that causes a loss of friction and causes issues wearing down the blade. I'm hoping I can get away without that, and the reduced speed should hopefully fling metal shavings not fully up into the top of it. I'll probably add some brushes here as well. But yeah, that's my ongoing process. It's probably, unfortunately, going to be about a month until the longer wheel comes, when I can drop the speed. But, or when the longer belt comes so I can drop the speed down. But as mentioned, the bearings should be here this week, and I can hopefully swap those out. And yeah, this is just going to be sort of like a rolling upgrade to the saw to turn it into, well, from like a sort of crappy wood cutting machine into hopefully fairly decent metal cutting one. I think it's probably a really promising option for a budget metal cutting bandsaw, especially since those 1/2-inch blades do fit. That's going to give more stability in the cut. The guides seem to work fairly well. It's nothing too fancy. I do wish it had a little more cut distance here, just for cutting down scrap, like a whole intake manifold feeding it through. But again, for a saw with a really big, I think they call it resaw capacity, it's just really expensive. So for sort of like a low-level use and like small metal casting things, cutting up ingots and scrap metal and bad castings, I think one of these is actually going to be a really good option. So, yeah. First thing to do, I guess, the starting capacitor might be 40 years old, so test that. So, I've gone ahead and pulled out the starting capacitor, and it's apparently a 250 volt, 16 microfarad MPP capacitor. And I've got one of these little multi-function, quite scratched up, even though it's basically new, one of these multi-function component testers. So it does, I think, inductance, resistance, capacitance, also diode testing, transistor testing, that sort of thing. We'll go ahead and turn it on. Okay, so it's reading as a capacitor. 15.68 microfarads with 0 ohms of electrostatic resistance. This apparently also decodes infrared. So my phone uses a laser autofocus, and oh yeah, it's got an infrared port, so it's decoding this autofocus signal as some sort of infrared signal. Alright, so don't mind the slightly weirdness from some forest fire smoke allergies that are keeping me up till 5 a.m., but my part just got off the printer, and it turned out really nice, actually. This is one of the better print results that I've had for a while. There is a slight layer step in the end there. I think just from a little pet G booger that got in the way. And you know, as always with carbon fiber PET G, this is 20% by weight, 80% by volume carbon fiber. You can see there are some little boogers that got in the way just from on the nozzle. But overall, that print turned out really nice. And that is a really just super nice, rigid part. I mean, I don't see a need of doing this in aluminum, and I'm glad I didn't bother doing it solid, because this thing is just solid as hell. Yeah, and then I have the wheel off the bandsaw. It may be a little bit of a tight fit, but I just need to line those teeth up. There we go. That presses on there. Maybe not quite fully. Or maybe that's just because I extended the little width on this by 1mm to add that little backing section there, which will hopefully help prevent the belt from coming off. Could be a bit wider maybe, but I think that's pretty good. So that right there is a really nice result on the increased pulley diameter to drop the speed of the bandsaw. Now I'm just stuck waiting on the new belt. Alright, so today has been a good day for mail coming on time. I've not only got now the correct sized bearings in, but the belt, which I thought was not going to arrive for another 7 days, arrived too. So I've done a little testing myself. This slows it down nicely. It also makes the bandsaw actually start every time now without any issue. Yeah, just because of the tension issues, you can't have the tension on very high, and this will sometimes still, depending on the blade position, not start well. But with that wheel on there, it increases the torque, and therefore it starts a lot more reliably. But I figure I'll grab a video of it running, just with the stock speed, and also with the old bushings in before I go swap them out. I also went ahead and added some LED lights on. So there's a strip here, and a strip of 3 here. And that helps a little bit. I've got really big LED lights I mounted up in here, so it's not a big deal. But in lower light, it'll definitely work better. So this is with the stock sintered bushings, as well as just the regular speed. Ah, right there. So you see how that didn't start well? That's just because it was in a bad position, basically. And yeah, you can hear this scraping. Let's loosen the tension off a bit. Yeah, it's not too happy with this. Alright, so let's go ahead, pull these wheels and the blade off, and then get some proper bearings in here so we can tension it. Alright, so yeah, we're going to punch these out, and it was actually kind of anticlimactic. That's all there is to it. And there's actually a lip in the middle of the wheel that stops it from being pushed in too far, so you can't push them out both through the same way. And then I've just got some carbon fiber PET G printed pieces to space them out properly in the actual drive wheel, and I mean, this isn't actually going to be needed for the others, I don't think. Yeah, perfect. Let's clean that maybe. But yeah, you get the idea. So we're gonna finish this up and then switch back over to the bandsaw. Alright, so I've got the wheels back on with the bearings, and I mean, wow, those just spin so much better. It's insane. This one spins really nice too. The actual loudest bearing now is actually in the motor. As you can hear, that's pretty noisy. Ah, shit. But I'm going to go ahead and put the band back on and see how tight I can get it now. I got that to the point where it's actually pretty tight. Probably could be tighter, but it's not. If I tighten it much more, or if I adjust the camber much more on the top wheel here, it will start to rub against this rear bearing, and that's about as far back as I can get it. But that right there is pretty good. The blade is staying nice and straight on both bearings without much adjustment. So I'm going to go ahead and just test it up, and we'll see how smooth it sounds. Now that all of these bearings are replaced, I can already tell you, like, this is turning with momentum when it's way tighter than it was before. So upgrading your bushings to actual shielded bearings, 100% worth it. Alright, so that's on. I'm going to grab the power cord and stand back. And let's see. Oh my god. Listen to how quiet that is now compared to before. Like, I can actually talk and you can probably hear me. Oh, that is just purring along. And it's starting up each time with no issue at all, even though this is way tenser, because the rolling resistance of those shielded bushings, or those bushings, is just so much lower with these bearings. The motor can actually start with this much tension on the blade. And being a thicker blade, it's also a lot stiffer. So that right there is our top guide assembly, and that one is all positioned properly. So you'll see that thrust bearing is not being moved unless you cut on it. And then the bottom is about the same. Now we have our bottom section. This screw on the side here. Oops, that one came out as well. This screw on the side here will let us get this just into place. Again, so that this back bearing here is not spinning with the blade. That could be a lot closer though. There we go. And then let's just get that into place. So the blade still has a little bit of a wiggle in it there. So those guides, I might want to put them in further. But that wiggle means that it's going to be rubbing against them pretty consistently, I think, if I don't have a fairly generous amount of gap. So then I'll go ahead and plug this in again, and we'll take a look at it. Alright, so I'm going to put this back together, and then we'll do some test cuts at the stock speed and the modified speed. Alright, so I've got some dull wood, I've got some shiny wood, and then I've got some brass. And we're just going to do some test cuts. Sorry, that's not the piece of wood I'm going to cut. That's the piece I'm going to cut. So the nice thing about using this pulley that I designed is that you'll be able to keep using the high speed for wood, but then if you want to do aluminum, you can just slap this lower speed pulley basically onto the bandsaw and drop the speed instantly like that, with a minute of work maybe. So let's do some test cuts at the stock speed with the new bearings. You know what? Something changed, because that blade is not staying in place now. Okay, so retensioned, it's actually pretty finicky to get this thing to tension properly. It's a lot of balancing between the tightness and the like the camber at the top. Improving that mechanism might be nice. It's still maybe looser than it should be. I've seen a bunch of different ways, methods of either sound or like how much it deflects. I don't know, it's better than it was before by a long stretch. So let's go ahead and do some test cuts at normal speed. And I was kind of thinking of replacing this part anyways, because it's plastic and kind of crappy and stuff, and this wasn't lined up very well. So I think I will maybe cast one of these in aluminum and have that as a new part for this thing. So I think that's like pine or something. Then we have our shiny wood. Our big old brass. Gonna hit this with a little bit of wax. So let's go ahead and take a look at these cuts. So this is quite warm, but our brass looks pretty nice, fairly smooth. We have our shiny wood, or aluminum, if it'll focus. Lots of pitting in that. Pretty smooth though. And then we have our wood cut, which is, yeah, pretty nice. So let's go ahead and swap this over to the slow speed. So that's literally just going to involve... Actually, let's go ahead and drop that down too. Alright, so we pull those three off. Wow, lots of material already in here. Damn. I'm going to have to look at getting some brushes. Yeah, some sort of little brush that like goes here and helps scrape the wood off of there, or the dust off. Then we'll take our carbon fiber 3D printed pulley, well, carbon fiber reinforced PETG. We'll just line that up on there, like that, and then we take our new belt. And so I can't recall exactly what the speed reduction was, but I'll post it up on the screen now. It's a significant decrease in speed, and as well as linear feet per minute. So now I'll turn this on so you can see how much slower it's going. Definitely going slower on the wood. I'm just gonna see if this gets some of that sawdust out of there. Here's another piece of aluminum. So that still cuts through nicely. And we'll take our same piece of brass. So I'm not sure what that thunking is when I press into the blade. I might want to look into that. So yeah, I'm not sure what that clicking is. I looked and I noticed this thrust bearing on the back was actually not getting engaged by the blade and spinning while I was cutting, so that might be part of it. Well, we'll go ahead and compare our wood cuts, which are basically identical from the look of it, if this will focus. Then we'll take our aluminum, which is the part that I actually cut. So in theory, these cuts should be better quality. The material has a lot less heat in it. It's definitely not as warm as it was before. Those cuts look pretty much identical. But this should also help prevent chip welding with aluminum. Now if we take our two brass cuts here, it's hard to say if there's really any improvement on those. I feel like those are pretty much identical. They're still not very smooth. I can feel a lot of variation on the surface of the cut there. It looks like where I broke through, it's a bit cleaner just because it went slower. There's not a little thin section like that. But it should be safer for cutting metal, which is the big thing. I think running at the high speed for aluminum is fine, and the speed cutting is pretty nice. The speed advantage is also pretty nice with brass, and the high speed I think is probably okay for brass as well, but a little less suitable. But if I wanted to do anything like steel or anything harder than aluminum, I'd really want to reduce the speed of this thing down to the slower setting. So yeah, I mean, it was not an expensive mod to replace or to design and make that pulley. The belt was only like $18 or something like that, I think. So perfectly reasonable. I can very easily switch back to the high speed blade if I want to do wood or anything like that. I'll figure out what that clicking is, but as you can see, this is working pretty darn well for cutting aluminum. And the other thing is, at the lower speed, there's not much high frequency noise coming out of the aluminum being cut, which means ear protection probably isn't needed as badly as it would be if I was running this at full speed. So yeah, hopefully this was useful or informative or entertaining for someone. These little Craftsman bandsaws can actually make pretty decent metal cutting machines, as long as you get the appropriate blade. And I'd highly suggest replacing those bushings with bearings, because then you can actually tension a 1/2 inch diameter or 1/2 inch width the blade properly. So yeah, there you have it. We'll be seeing this in some future videos when I'm cutting up scrap metal or cutting sprues off a molding. Well, off of a mold, not a mold.